All right. Thanks, Santosh, for reminding. Uh, all adult websites should be blocked. I have another requirement over here. Let's say block gaming websites or gambling websites. These are the obvious ones. But also, you might be surprised, a lot of the companies also ban or block news websites. Why would companies want to block the news websites? The reason is they don't want their employees wasting time reading news when they're supposed to be working or being productive for the company. Now, the problem over here is, yes, you do have the ability to do filtering based on websites, both on the firewall or on the router. But the problem over there is you need to individually specify the website that you want to block. If I want to block all news websites, I would need to figure out the website names of all news websites that I want to block. That's where a filtering device like your WSA kicks in. It used to be a company that used to do that called Ironport. Cisco acquired that company, and now the same company, that capability is in this device known as the WSA. What does it do? These clients, these PCs, their default gateway is pointing towards the router or the firewall, the edge device. When the request is sent to the firewall or a router for a web request, you have the ability to configure the router to redirect that request towards a WSA device. This connection between the firewall, router, whatever your edge device is, and the WSA is handled by a protocol known as the WCCP protocol. Specifically, it uses V2 to set this relationship up. So I set the relationship up between the firewall or the router, whatever your edge device is, and the WSA. I configure the router. If an incoming request is for web, forward that request towards the Ironport device, the WSA device. Once the WSA device gets it, the WSA device, in turn, what it does then is it first checks its filter to see if that particular type of website is blocked or not, or allowed or not. That's the whole purpose of the WSA. Rather than creating a list of websites, it has an internal database in which websites have been categorized into different type of categories. So you'll have a category called adult content. You'll have a category called gambling, news, social networking, sports. These are all pre-created categories, and inside this database, it has categorized the website as either adult, gambling, news, social networking, sports. There's a bunch of different categories. I'm just listing some. Now, what you can do on your WSA is specify that this particular category that you have should be blocked for this particular user. So you have the ability to put your filtering over here to do that. Does that make sense? So all these websites can be blocked by the WSA by looking at the category. The category inside the internal database has the list of all the major adult content websites, gambling websites, news websites. So it'll block the request and it'll send a message, a web page to the client saying, hey, listen, the company has blocked this type of website. Now you might say, well, new websites are popping up all around the world every minute, which is absolutely true. What the WSA has, it has an internal engine known as the Dynamic Content Analyzer. or the analyzing engine. What this engine does, it has been loaded with the characteristics that helped the WSA to categorize a website as an adult website. So there's certain characteristics of a website that make it an adult website. Those characteristics are built into this engine called the Dynamic Content Analyzing Engine, or the characteristics of a gambling website, or a characteristic of a news website. What helped the people analyze this website and say, hey, this is a gambling website, this is a news website. Those characteristics are inside this engine. So let's say somebody is going to an adult website, and that adult website does not happen to be in this database. So it says, okay, it's allowed. The packet comes into the WSA, it says it's allowed. It then in turn, because it's a proxy, will send the request to whom? To the internet. Okay? To that web server saying, please give me that page. He will respond back to the web server. The web server forwards the packet to the client. So all the packets are going through the WSA. At the same time, the WSA caches that page if somebody else wants to use it. They have a local cache of the packet. So that's a caching capability it has. But at the same time, it's analyzing that uncategorized website. Does it have any of the characteristics that I used to match that website as a certain category? It was an adult site that I went to. Yes, it was not in that list, but as more and more packets come through, it figures out, hey, listen, it has all the characteristics of what? An adult website. So dynamically, what it does, it adds that new website to this particular adult content website and blocks traffic. So initially, maybe 2, 3 packets, 4 packets might make it through, but eventually that website will be categorized as an adult website and be blocked. You guys understand that? Very dynamic type of setup. Clear? So the WSA provides 2 main capabilities. What are the 2 main capabilities? It caches the website. So let's take a good site now. Let's say somebody went to Cisco.com. Cisco.com is allowed. Again, the packet flow is going to be like this. The packet gets forwarded to whom? To the router. Router, because it has that relationship with the WSA, it sends that request to the WSA, redirects the request to the WSA. WSA says Cisco.com is allowed. But then what it does, it creates a brand new request and sends it to whom? Cisco.com on behalf of the other guy, but the source address is the WSA address. The return packet from Cisco.com comes into the WSA. He caches it. So Cisco.com's content is now cached where? Locally on the WSA, and a copy is sent down to the client. The next person trying to go to Cisco.com will go to the WSA. The WSA makes a quick check in the version of the Cisco.com website. If it's the same version, it gives the web page locally. So very little transfer is done with the website. Does that make sense? Good? Everybody okay with that? Surya, Santosh, Vijay, Rohan, Palani, Emmanuel. All right, so that's what the WSA is. Now over here, to set this up, I'll show you how to initialize the WSA from scratch. Once I've initialized it, I am going to set up one of the routers as a web server, put a bunch of different websites. I'm going to create a DNS server also on the router so the websites can be accessed through DNS. Okay, and then filter them. You guys okay with that? Let's go ahead and do that. WSA can come as an appliance, or WSA can come as a virtual device. Just like your ACS server can be an appliance, physical appliance, or it can be a virtual VM image. The same thing with the WSA. All right. So the first thing that I'm going to do is I'm going to show you the diagram, the topology that I'm going to be setting up. Let's draw that out for you guys, and we'll stick to that. Start with the cloud. This is the internet. Think about, actually, take that out. We'll do the routers. Router over here, another router over here. Now what I'm going to do over here, I'm going to use a firewall as well to exit out, but just remember, on a normal network, you'll either have a router or a firewall. So you're not going to have this type of setup in real life. It's one or the other. But here, just to show you how the relationship is set up between the firewall and the router, I'm going to set up a firewall as well as a router. This is your internal network now over here. This is my WSA, and these are PCs down over here. All right. Let's put this as the 192.1.100 network, and we'll put this as 200 network. Think about this being the internet. Think about this being a site on the internet. All right, I'm going to create different sites on router 2. But before we do that, let's set this network up over here in GNS. This is the network that I'm going to be working with. This is my WSA over here. Cool. So bring up my GNS. Router. Which one did I put where? 1 second. 2 on the outside, R1 on the inside. Router to the internet. I'm going to put a switch over here on the outside. And just so that I can show you the relationship, I'm going to put a firewall over here as well. And on the inside, I'll also put a switch. This is my inside switch. And here I'll connect my cloud. Cloud is going to be my WSA, so let's just change the symbol first. Just some type of symbol. Change the host name, WSA. Because it's a VM, I will also have a PC down here. I'll just draw it out manually. This is my outside. This is my inside. Now over here, I need to connect my cloud. I'll connect my interface. I have a special loopback that I have designated for that, the WSA. Connect it. Now I can connect this WSA interface to the internal switch. Just remember, this interface is also connected over here. Hypothetically, this is my VM for WSA. This is my PC. Both are physically the same device, but here it's hard to draw that other one. So that's how it's connected. Cool? Good? So let's launch this. And in the meantime, I also want to launch my WSA. There's a WSA that I have. Virtual WSA, I'm going to revert to snapshot blank. So it's a blank WSA right now, but I'll still do a reset on it so that you can see how to reset a WSA and restart it from scratch. Let it come up. All right, it came up. First thing that I'll do is I'll reset it. The way you reset it is typing in a command called reset config. Give it some time, it will reset the entire WSA, it scratches it up. Once it's scratched, it is defaulted. I can now configure it based on my configuration. It'll come back, the prompt will come back. All right, so once the prompt comes back up, you type in interface config. This allows you the ability to manage this interface of yours. Which interface is this? This interface. This is also known as the management interface. So the interface that I'm configuring is the M interface, or the management interface. If you want, you can use a separate interface to do your data, which is called the proxy interface or the P interface. Or you can use the same interface for what? Management as well as data. For here, I'm going to use the same interface for management as well as for data. So one interface. It needs to be given an IP address as we agreed upon based on the diagram. We're going to give it an IP address, let's say of 192.1.200. A number. Let's pick the number over here. Let's put it as 50. That's the IP address of your M interface or the management interface. So the PCs will also need to be on the same network. Let's do that over here. You type in interface config, says what do you want to do? I want to edit the interface. Which interface? One. One is your M1 or the management interface. What IP address do you want to give it? I'll say 192.168.200.50. The subnet mask, the host name, says, do you want to enable FTP on this interface? No, I don't really care about FTP. Do you want to enable SSH on this interface? Let's say yes. What port? 22. Do you want to enable HTTP on this interface? I'll say yes. Which port? HTTP, it uses it doesn't use the default port of 80. It uses a non-standard port of 8080 by default. If you want to keep it as 80, you can always change it. Do you want to enable HTTPS on this interface? I'll say yes. Again, it does not use the default HTTPS port of 443. Instead, by default, it uses 8443, not 443. You haven't entered an HTTPS certificate to ensure privacy, run cert config. Do you want to use the demo certificate? I'll say yes, that's okay. Both HTTP and HTTPS are enabled for this interface. Should HTTP request redirected to a secure service? Basically, what it means is if somebody does a web into 8080, do you want it to be redirected to 8443? I'll say yes. The interface you edited might be the one you're currently logged on to or into. Are you sure you want to change it? Change the IP? Yes. Once I'm done, enter. I'm not done yet because I need to commit. Once I commit and I've saved this config, for the virtual image, it's recommended that you stop this, power it off, let it come back up with these configs because I've saved the configs now. Let it come back up. It's like applying the changes. This is only for the V image that I have that needs to do it. On a real appliance, once you commit the changes, at this point, you could have browsed it. While it's coming up, what I'll do over here is assign the IP address to my PC and configure the rest of the devices. So let's do the IP address of the PC first. That's the initial config from the CLI for your WSA. Adapter settings, WSA, properties, .192.1.200.65. This is good enough. Now, at the same time, I'm going to configure the other devices on this network, R1, which has 100 on the outside and 200 on the inside. based on this diagram over here. All right. Anytime now. It's because of the WSA, it does take time because it's a resource hog. It's coming up, that's why it's taking time. Oh, good. It's also logged in. All right. R1 just came up. 100.1 on the outside. 01, 200.1 on the inside. 200.65 was my PCIP and 50 was my WSA. I believe it's still probably coming up. I set that to 250. Oh, 168. I would need to change it. See if it works this time around. Yep, this guy is okay. IP route 0000. 100 dot, or actually 200.2, which is going to be router 2. Let's configure router 2 now. All right, I'll put a route for the 100.0 network through 200.1 because I want reachability to the 200 network. .200.2 is good. Oh yeah. This should be 100.1. Sorry, 100.2. This is the 100 network, this is the 200 network. So now Communication is working fine on my R2 because it's going to simulate the internet. I'm going to create a loop back. I'll enable the HTTP server on it so people can log into it. On my PC itself, because I want reachability, I can't change my default gateway, but I can at least do this. Route add 2222. If I want to reach this guy, go to 200.1. Should be able to ping it. Can I ping 200.1? Okay, this is good. Let's go over here. Same issue. My default gateway, I've put it wrong. Now let's try it. There you go. So my PC over here is able to communicate to R2. The WSA is able to communicate to R2. Because doing web filtering, I need to do my DNS. For the WSA, I'm going to use R1 as a DNS server. How do I set up R1 as a DNS server? Let me show you. IP DNS server. Turn it on. Point to itself as the name server. 100.1, which is, or 200.1, which is my address over here. Now I can create some hosts, your routes, or basically your domain names. I can specify that this IP www.cnn.com is 2222. Host www.espn.com is 2222. IP host www.toi.timesofindia.com is 2222. Similarly, we can do espn.com. So I'm just doing this so that I can test it. Creating hostname entries. What other type of www dot? Let's say that we got that. This is good enough, I guess. This is good enough. These are the different websites that are there. So because I am the name server, I should be able to ping. Sorry. Notice it's going to 2222. I want to do the same thing over here, but I cannot change my DNS server on the PC. So instead, what I'll do is I'll edit my host file, which overrides my DNS server for certain entries. I'll go to the C drive, Windows. In real life, you would always point towards what? Your DNS server. I'm doing the DNS server manually over here on the host file. Windows System 32, drivers, etc, and the host file. I'll edit this file. I think I had some entries from the last time I did the lab. I'll just modify those. I think I do. I'll just come up. Gee, I might need to open it up in Notepad. directly. File, open. C, Windows, System 32. Drivers, etc. All files, I'll open the host file. Notice I did a comment on this. I'll just take the comment off and I'm gonna be good to go. So all these websites are there. Let's try CNN.com. www.cnn.com. It should work. I'm setting the base up so that I can actually go there to these sites. All right, it's going to 2222. So my network is set up. I just wanted to make sure my network can browse now to these sites. So if I go over here now to my browser, I can open my browser up. I can type in HTTP. Come on. http://, let's say CNN.com. It goes to router 2. Why? Because I have that host name pointing to it. So I'm going to router 2. Or for that matter, I can do ESPN.com. It'll also go to router 2. Because I'm pointing everything based on what? Based on my host file towards the internet. R2 is going to act as my internet router for all these different websites. So set the topology up. I set my WSA up. Now let's see how to configure the WSA. So on my PC, what I'm going to do is I'm going to do https://www. Or actually not www. 192.1.200.50. The IP address of my WSA 8443. It should make a connection to the WSA. Advanced. Proceed. Login. Admin is the username. The default password is Ironport. And I'm in. The first thing that you do as soon as you get in, enter your WSA, is go to System Administration, run what is known as a System Setup Wizard. It completes your config of your WSA. It says, what is your DNS server for the WSA? I'm going to use my DNS server as my router 1. .200.1. All right. Next, for the name, I don't have any other web proxy on the network, so I'll just click next. The IP address was 200.50, was pre-configured. That's okay. Next. I'm not using the data interface. My default gateway is different, 192.1.200.1. Make sure your default gateway is set correctly. Next. For right now, I'm not going to do the relationship between your edge device and your WSA. I'm going to show you how to do that later on. That's the WCCP v2 router. So I'll leave it as is. Put the password in, whatever you want to set it to. I'll just keep it at Ironport. Email alert, send it to Whoever, put an IP address for who your SMTP server is. Next, take the defaults and save. And once this is done, it tells you what your config is. Save it. As soon as you do that, you lose connection because it moves the URL to your, rather than the IP address, it moves it to your name, wsa.nh.com. And I don't think I created an entry for that. So it's going to fail, but that's okay. Once it fails, we'll go back in and use the entry to get it. See, this is okay. It has changed it to wsa.nh.com. I'm going to change that back to 192.1.200.50. I'll show you the redirection as well, 8080. It should redirect it automatically towards 443. And I'm back in. That's how you initialize the WSA. Any questions so far, guys? Basic setup on your PCs and the network. I haven't done anything special on the WSA to set it up. I just set the topology up. I initialize the WSA right now. Any questions, guys? Emmanuel, Santosh, Surya, Rohan, Palani, all good? Now, if that's the case, we'll go ahead and start configuring the relationship between your WSA and the router. I'm talking about this relationship over here. So I want to show you, actually, let's do the router first and then we'll do the, I'll show you the firewall as well. I'm talking about setting up a relationship between what? The router and the WSA, in the sense that when the PCs over here send it any traffic, it should redirect the traffic towards the WSA to check whether this traffic is allowed or not. If it's allowed, the WSA will send the request on behalf of the client. To whom? To the device on the internet, and get a response back. Let me demonstrate that to you guys as well. I will go to router 2. Remember, I had browsed to the router a couple of times. There's a command that you can do over here. Go type in show IP HTTP server history. Nothing over there. There's no redirection. So if I go to my PC over here and open that website, www.cnn.com, it will make a connection to router 2. If I go over here and check the history, actually on router 2, I need to check the history. Show IP HTTP server history. Notice who's making the connection. 20.65, the PC, is making the connection directly right now. There's no proxying happening right now. You guys okay with that? You understand that? The actual connection is being made by this PC over here, his IP address over here. Right now, the connection, because there's no redirection going on, this IP over here is 65. He's making the connection just using normal routing to go through the router to get to router 2. He gets a packet coming in from 192.1.200.65. There's no redirection. So it's not going to the WSA right now. That's what I want to do over here. I want to set this relationship up so any request that comes in into the router, I want to redirect that request to whom? To the WSA. It will check for the filter to see if it's allowed or not. If it's not, if it's allowed, then it will make a request from the WSA over here. What's the IP address of the WSA? .50. From this point on, when I configure this redirection, all the requests coming in over here should be coming in from 20.50. Does that make sense? All right, so let's see how to do that, how to set the relationship up. Let's do it on the WSA first. On the WSA, the place that you go to make that connection is under Network Transparent Redirection. I'm going to edit because I said no device. I'm going to change it to WCCP version 2 router. Submit. Add a service. The default service is called Web Cache, which is a service ID of 0 with a destination port of 80. I'm going to use that. All right. You guys are okay with that? What is this number 0? It's a special, let's say, a service ID that links up the WSA to the edge device. If I use the service ID 0, which is Web Cache, I need to use the same service ID when I configure the relationship up on router 1. If I use a different service ID, I need to match that service ID on the other device to match it. So because I use the standard service, keep that in mind, I need to use the keyword Web Cache, which is service ID 0. What's the IP address of the router? 200.1. If I want optional, I can enable a password over here. Let's say Cisco. And once done, I click on submit. One thing that you need to understand about the WSA, as soon as you submit something, it is not done until you do this. And the problem over here is because I have too many windows open. There's a thing that pops up over here that says commit changes. Unless you commit the changes are have not taken effect, like an apply. Now it's okay. So my WSA has been configured to point to 192.1.200.1, which is using the service profile of 0, which is the service ID called Web Cache. I need to do the same thing on the router side. How do I do it on the router side? My router over here is router 1. Let's go to router 1. Couple of things I need to do over here. Create an ACL, standard ACL, 1. Permit host, the IP address of the WSA. Another ACL, I'm going to specify what traffic needs to be redirected, which is, let's say, 80 or 8080. This is called the redirection ACL. The first one is the WSA ACL. Who is my WSA? On the router, first thing, I need to change my version or set my version to 2. On the ASA, it's done by default. On the router, you need to do it. So far, so good. So you have a couple of ACLs created. You have set your ACL for redirection and pointing towards the WSA. Now now this is done. You need to configure the WCCP service. I configure the WCCP service by specifying IP WCCP followed by the service ID. What's my service ID over here? That has been configured on the WSA pointing towards router 1. What's the service ID I use, Emmanuel? Santosh, Surya, Rohan, Palani, anyone? What service ID did I use over here? 0, which has a special name. What's the name? Web Cache, right? So over here, what I do is I say IP WCCP Web Cache. All right, followed by what is known as my group list. What's a group list? It's the list of my WSA, the IP address of my WSA. So when I say group list 1, I'm pointing towards 200.50. What traffic should be redirected towards this WSA? That is defined in my redirect list 101. Basically, it's telling me that if a packet comes in to Web Cache for 101, which is TCP 808080, redirected towards 1. 1 is your what? The WSA. And because on the WSA I set the password, I need to match it. As soon as I do that, it says line protocol changed to up, some line protocol changed to up. Which one? IP WCCP Web Cache View is a command that sees if the router and the WSA have communicated to each other at this point or not. It doesn't seem like it yet because it says WCCP router none. Client is there, but the router has not communicated to it. Right now it says service web cache acquired on WCCP client. Now if I do IP WCCP web cache view, you will see that the router sees the client sees the router. The client in this case is the WSA. Clear. One last thing that I need to do over here. I need to apply this under the interface. In my case, the interface towards the inside is F01. You can check that by doing show IP interface brief. 200 is towards the inside. So under F01, I'll say IP WCCP redirect. The service ID, which is web cache, IP WCCP web cache redirect. Any traffic coming into F01 should be redirected towards web cache. Web cache is that service that I specified over here. Web cache is this thing which is pointing towards what? Let me show you the command for that. So as soon as I say web cache, it says, oh, I need any traffic coming into this interface to be redirected towards web cache. Web cache points to this WSA for this traffic, and the relationship is set up based on the password of Cisco. So now any traffic coming in, it will be sent towards the WSA. Let's try it now. Let's do this over here. We'll do www.espn.com. Made the connection, no problems. Let's check over here something. Let's do a show IP server, HTTP server history. Notice the last request came in from where? 20.50. So the actual request did not come in from 20.65. It came in from 20.50. If I clear no, it's not clearing it. I'll make another request. It's blocked as malware. Let's try another one. These are default settings on the WSA, but you know it's now going through the WSA. There you go, XXX is allowed. Waha. A lot of people in the company will be happy. Coming in from where now? 50. 65 is not being used because everything comes into the WSA, WSA forwards it across. You understand what I'm showing you over here? I haven't configured any basic policies. I just wanted to show you the setup. Now, let's say you didn't have a router over here, you had a firewall over here. That's why I drew this. Let's say I didn't, my edge device over here happens to be a firewall, not a router. So how do I set this relationship up? I've already used the web cache for some other device. So web cache, the service is used. Once it's used, you cannot use it for anything else. So 0 ID is being used. When I set this relationship up over here, I need to use a different ID, and you'll see that. So now I'm just going to show you how the firewall sets up with the WSA. Subtle differences, but I want you to be aware of it. So I have this device already. I want to add another one. Guess what? At this time, the web cache service is grayed out because it's already being used. Not available, already defined. So I'll create it as firewall, give it an ID, any ID. Let's say 55. Port number 80 that I want to forward. The address is 20.10. 20.10 will be the IP address of my 200.10 will be the IP address of my firewall. And if you want, optionally, you can put a password over here. Good. Although I've done that, it has not been committed, so I need to do what? Commit changes. What ID did I use? 55. So now let's go configure my firewall. Outside is okay, inside is not okay. Something wrong with this interface. E1, it's connected. .200.10. Let's save the config. Reload, because there's nothing that is wrong over here. Just reloaded the device, it's done, it's okay. Now, again, I need to configure the relationship between the firewall and the WSA. Now, I don't need to do WCCP version 2 because that's the default. I need to create an ACL. I don't have a numbered ACL. I'll create a standard ACL. I'll call it WSA. Permit IP host, the IP address of the WSA. Hold the address in the source part because it's an extended ACL. Access list, let's call it reader. Permit TCP any EQ 80, and I want to redirect 8080. Done. Now I'm ready to configure my WCCP service. WCCP, I don't say web cache because web cache is 0. I'm not using that. I'm using what instead? 55. You get my point? If I was using web cache, I would say WCCP web cache, which is already being used with the router. So I'll use 55, the ID that WSA is pointing to me as. Group list, WSA, reader, redirect list, reader, password was Cisco. That's how you create the same thing that you did on the router side. Okay. Now I need to apply to the interface. WCCP 55, or actually WCCP interface inside redirect or 55 redirect in. Basically saying what? On the inside interface, I want WCCP to redirect 55 if the packet is coming in inbound. This is basically the applying of the 55 web service under the interface of the firewall. So the commands are a little different. Now, can you see if it's up or not? Show WCCP 55 view, not web cache because web cache was a service. And as long as you see these two up over there, it's good to go. Let me write these things for you guys in Notepad. All right. Configuring the router for transparent redirection. IP WCCP version 2. Turn it on. Create the ACL 1. Permit host the IP address of my WSA. Another ACL for what? Redirection traffic. 80, I can do another one. 8080. Done that. IP WCCP, web cache. All right. IP WCCP web cache followed by, that's the ID, group list 1, redirect list 101, password if it is set. The last but not the least, applied to the interface. In my case was F01, IP WCCP, web cache, the service, because I use web cache as a service, redirect in. I'll do the same thing on where? On the firewall. For transparent redirection, I don't need to specify this because WCCP is version 2 on the firewall. Access list is a numbered, named extended ACL. So I'll say permit IP host any. Again, this becomes a named ACL. The contents can remain the same. WCCP, remember I used a different number. I could use this. The IP goes away. I could use this. Group list, I used WSA. Redirect list, I called it reader. Password is the same. This command is a little different. WCCP interface inside the number redirect. And that's how you configure your relationship. And you need to match it on the other side. What's the verification over here that they are communicating to each other? Show IP WCCP web cache view. And for this guy, it's almost the same. Show, I don't have IP, WCCP, web cache. I don't have web cache, I have 55. What is redirect in? When traffic is, I'm applying this to my inside interface. What I'm telling this inside interface is, if a traffic comes in to this interface, redirect it if it matches it based on the WCCP towards this guy. So the direction of the packet coming in, that will be redirected, inbound or outbound. For example, if I add multiple segments over here, rather than doing it on each and every segment, I could specify that redirection. I would apply that redirection not on the inside interface. I could potentially apply it on the outbound interface. What does that mean? When the packet is leaving this interface out, check it over there at the time. It's basically like you apply your ACL. Where do you apply it? What direction do you apply it? What traffic do you want to redirect? Does that answer your question? Once you create the WCCP globally, it doesn't automatically apply it. It doesn't automatically redirect it. You need to tell it what traffic are you going to redirect. Brilliant. Good. So I'm now ready to do my web filtering. My caching is happening. I showed you that. Now the next thing to do over here is my filtering. How do I set it up? In order to do the filtering, you need to have a couple of things in place. Number one is the identity. Identity is the person that you want to do the block based on. And number two, you need to have the access policy. This is where you define this identity should be able to access what? The identity over here, when we create it, we're going to create it based on an IP range. It's going to be created based on an IP range. Either a single IP, an entire subnet, any type of range. If you want, you also have the ability to integrate WSA with AD. If you do that, then you also have the ability to download the usernames and groups from where? AD, and the identity can be linked up to the Active Directory. I don't have an Active Directory over here, but let me show you where it's done. If I wanted to do an Active Directory integration, if I go over here, one of the options that I have is authentication. Let me see where is that, right here under network, authentication, add the realm. Over here, realm name, I call it my AD, doesn't matter. Here, I go in and specify that I want to do it based on NTLM. NTLM is your Active Directory. Once I specify that, you specify the IP address of your domain controllers over here. The Active Directory domain name, computer count that you want to join, and it would basically at that point download all the group names and the usernames. Once you do that, they become available over here. But that's how you do it. Once you do this, then when you go create the identity, you have the ability to link it up to a particular group as well. Right now, I don't have Active Directory, so the only thing that I can do over here is link it up based on IPs. I can only create the identity based on an IP. From the exam perspective also, that's all you got to do. How do I create the identity? Right over here under Web Security Manager, Identities. Add an identity. Let's call him employee. All right. Over here, you would specify the IPs 192.1.200.1, or let's say 51 through, let's say 100. That becomes my identity range. If you wanted to do the entire subnet, you could do 0/24. In my case, I'll just do 51 through 100. Clear? This is where you would need to specify what? Define additional group membership criteria. Well, actually, if you wanted to do the group, it would be over here. Under advanced, though, you do have one more option. You have the ability to specify what are known as user agents. What are user agents? Let's click on it. You can specify your browsers. So you can specify that this particular identity can only use these browsers. By default over here, it's only giving me an option of what? Internet Explorer, Firefox. You do have the ability to go and pick a particular characteristic of a custom user agent that might have things like Chrome and all. So if you want to restrict it to a particular what? To a particular browser, you can do that as well. Where to do the exclusion? What exclusion are you talking about, Ron? Okay, I haven't gotten there yet. I'm just creating the identity at this point. The exclusion is the access policy for this employee. All right. So first you create the employee and specify his IP range. Done? Once you click submit, you have this employee with a range of 200.51 through 100. Commit changes. And you're done. Now, once you are created your employee, I'll create another one. I'll create managers or execs. Their IPs are 200.101 through 254. You understand what I'm doing? I'm doing it based on IPs because group names are not available over here to me because I don't have Active Directory integration. Even with IPs, I have quite a bit of control. Once I do that, I don't forget to commit the changes. Done? Now that I've created my identities, I can go to Web Security Manager and Access Policies. This is where I create my access policy. I'll click on Add because I want to create my own policy. I'll create this policy. I'll call it Employee Policy. It's not for all identities. I want to do it for a specific identity. This is only going to affect it for what? The employee. I could have done it with an additional group membership. I can't do it because I don't have authentication. Submit. Once you do that, client network PCs, yes, correct. So members are all clients. These are all clients where the people are coming in from. So now I have the employee policy over here. Here I have the ability to do the URL filtering. I go to global policy. These are all your different categories that you have. Take a look. Adult, let's say I want to block adult. I'll just click on that. I want to block, what else? Entertainment, it's work that you want to do. You don't want to do entertainment. Gambling, I want to block. Hate speech. Pornography. Social networking. Sports. I left news off, so news should work. Sports is blocked. You see that? News I did not block. Should be an N. See, news is allowed. Palani, you're good with this. These are your categories. But these categories, these policies are going to be specific to this particular employee. You can also do application filtering. Let me show you what application filtering allows you the ability to do. For example, I can edit this. I can define custom. Here, these are some popular applications that work. It's not for everything, but it is for certain popular applications. What do they have the ability to do? Let's use Facebook, very common one. I'll click on plus. And under plus, these are different characteristics of Facebook. For example, I don't want to block Facebook completely, but I want to block certain characteristics. I want to block photos, for example. Block photos. So they can not do anything with photos. I don't want them doing chatting. The rest of Facebook is allowed. You get my point? So you can really monitor certain applications to a very deep level. Not everything, whatever is given to you. Once you're done with the policy, you commit changes. Now, what is the main sticking criteria over here? Sports should not be allowed. Adult websites are blocked. So if you remember XXX was working before, if I refresh this, it's not going to work anymore. It says this site is blocked because category pornography is blocked. The source IP that came in was 20.65. That's my IP. If I go to ESPN.com, which is again a sports website, also blocked. How about CNN.com? That's allowed. You guys okay with that? I would, Rohan, but right now I don't have that much time to do it because I also need to do IPS and wireless over here. I'm focusing on the things that are required, more required from the exam perspective. You can spend a day, 2 days just on WSA otherwise. You guys okay with what I showed you so far? The next thing I want you guys to understand is custom filtering. What do I mean by custom filtering? I want to block an entire web in particular category, but a certain particular one I want to allow or block. I want to make an exception. Can I go to juniper.com? Should not be blocked because it's a normal website, right? Now, what I want to do is I do want to block all the news websites, but ESPN.com is okay. So I want to make an exception to ESPN.com. So if I want to make an exception, the first rule of exception is create the exception. Exception, whether it's permitting it or blocking it, that I don't specify. I just create the exception. That exception creation is called custom URL categories. Add a custom URL category, give it a site. It doesn't, give it a name. It doesn't really matter what you call it. I'll call it 3 eyes. In here, I specify the name of the website. I'll specify ESPN.com, comma, you can say dot ESPN.com. That means anything that starts, that has that .ESPN.com. You know how you have www.espn.com, go.espn.com. .espn.com takes care of everything. Once this is done, click submit. So now III category has been created. ESPN.com. I didn't say whether to allow it or block it. Similarly, I want to create another category, IT or custom IT. In here, I'm going to put Juniper. Okay, it doesn't like dashes. So now I have 2 of these categories created. One has ESPN.com in it, the other one has Juniper.com on it. I didn't specify whether I want to allow it or disallow it. Their categories, the IT category is allowed, your sports category is blocked. I'll go back to my same access policy for employees. But now what I'll do is I will select my custom categories. Remember this? You see this over here? Select custom categories. This is III and custom. Do you want to use them? I'll say yes, include it in the policy. Custom IT included in the policy. Now by including the policy over here, it gives me the ability to make actions based on those policies. III, that was ESPN. I want to allow it. Custom, I want to block it. So I want to block Juniper, although Juniper should be allowed, the entire IT category is allowed, but Juniper should be blocked. It's a competitor. Along the same line, I'm allowing III, which contains ESPN. Do you understand what I'm doing over here? I'm making an exception. I blocked sports websites except for ESPN.com because I'm making that exception. I've allowed IT category, but I'm blocking Juniper. Once I'm done with this, I click on submit. And commit changes. Just to revisit the thing right now, you can see it now over here. III, which is your ESPN, is allowed. Custom IT is blocked. Cool? Let's check. Juniper, which was working right now, if I do it again, it's blocked because of a category called custom IT. And ESPN.com, which was blocked, now is going to be allowed. Sports is blocked, but I'm allowing ESPN. Very powerful in what it's doing. Good. One last thing that I want to do is time-based. I want to do a certain characteristic based on time. So for example, social networking over here. Is it allowed or is it blocked? It's blocked. I don't want to block it completely. I want to block it only during work hours. Okay? I want to block it during work hours only. So the first thing that I need to define is what are my work hours? Because work hours might be different in different countries, different places, different companies. So that is defined in what is known as a time range. Add the time range, work hours. All right. Use the time, Monday, Tuesday, Wednesday, Thursday, Friday. I work from, it's a 24-hour clock, let's say 9 o'clock in the morning till, let's say 9 to 5. And on Saturday, it is from 9 to 1. Submit. So I've defined the work hours. I haven't done anything with it. I just defined what are my work hours. Now what I can do is I can go back into my policies and I can define a policy based on a time rather than blocking social networking completely. This is what I have the ability to do. There's an option over here, if you take a look closely, it says time-based. Social networking, say time-based. If it's in the work hours, what action do you want to take? Block it. Otherwise, allow it. Allowing is just like monitoring it. Monitor it, see it, but allow it. Work hours, block it. Do you get my point? So it's not completely blocked. It's only blocked at the times. So you do it like that. So you do need to create separate ones. So you need to do 9 to 1, yeah, another row and time, absolutely. So you would do something like this. All right, so you would not do, let's say it's 12:30, 9 to 12:30, add a row. (1:30) to, let's say, not 1:30, sorry, 13:30 to 17. Do you get my point? So you need another row. So on, I'll just delete this so you can see it together. Monday, Tuesday, Wednesday, Thursday, Friday, 9 to 12:30. It's going to be blocked because my action is blocked. Monday, Tuesday, Wednesday, Thursday, Friday, from 13:30, which is 1:30 till 5. Again, it's blocked. And then I add another one for you Saturday. Saturday, you might just want to do 9 to 1, so no break. This is an or, this or that or that. Cool. Yes, you can. You have the ability to authenticate, but a lot of these things, if you really want to use them properly, because nowadays the IP address becomes very tough to manage. The reason it becomes very tough to manage is you have DHCP. So the IP addresses will be given out to different devices, different people based on availability. So managers and employees, if they're on the same network, which generally there are, let's say there's a sales VLAN, will have sales managers and salespeople all on the same network. It becomes very tough to do it based on what? These type of things. Generally, what you do is rather than doing an additional authentication, which is cumbersome for a user to type in authentication to go past, it is generally recommended to make it seamless for the user, have him log into the Active Directory. That forms the foundation of your authentication. You understand what I'm saying, Santosh? Rather than doing it over here, do it in your Active Directory. Because you also need to take a look at the user environment. Yes, it is a little extra security, but you want to make it usable as well. The most secure network is the one that's not connected. But then it's also doesn't give you a lot of capabilities. Good? WSA for you guys. Let's take a break. Let's take a look at what we needed to do if you've done that or not. Overview of what the WSA is. Not domains, groups. You know, in Active Directory, you have users that are members of groups in the Active Directory. Once you integrate the WSA with the Active Directory, those groups from Active Directory will be downloaded into the WSA. So when you create the identities, you can assign the filtering to a particular group rather than just an IP address. Got it? So let's take a look at the WSA. What are the different things that we need to cover and see if we've covered them? All right, so overview done. Basic initialization of the WSA, both through the CLI and from the graphical user interface. Configuring the firewall and the router relationship using WCCP. This is WCCP over here. Done that. Configuring identities, access policies, custom categories, and time-based policies. All done, all taken care of. Well, you can do URL filtering on the WSA, on the ASA. But the problem over there is you can set up, when you set up filtering, you're doing website filtering, not categories. The WSA does, ASA does not have website categories. It has, you have the ability to do layer 7 inspection and do URL filtering for a particular website. You cannot go on the ASA and say, I want to block all social networking websites. Potentially you can, but for that you need to figure out what are your social networking websites. List each one of them. Here, all you say, I want to block social networking websites. The work has been done by Ironport for you. You understand what I'm trying to get to, Surya? Is categorization enabled on firepower? No, not to the same. Firepower is more towards IPS versus web filtering. More a detection of attacks rather than websites. So what we're going to do in the next section, which is the IPS, those are the type of things that you would do on firepower. Good. So this is all done now. Let's take a break. When we come back, let's say it's 7:20 roughly, 7:35. When we come back, we'll take a look at the next device for the day, which is IPS. Good. Break. Just give me 2 minutes. I'll just draw something for you guys, and then we'll get started. All right, guys, this is what we want to set up. But before we set this up, I want to talk about what we're going to take a look at over here in terms of the IPS. What is the IPS? Why do I need it? Let's say you have a firewall. The firewall's characteristic or job is to block traffic. What does the firewall block based on? What is the characteristic that the firewall looks at to block a particular packet coming in? This is your firewall. This is the internet. This is your DMZ. And there's a web server down here. Let's say this network is 192.168.1.0/24. This IP is .5. If I want somebody over here on the internet to be able to use the .5 address, what do I do on the firewall? I translate it to a public address, let's say 192.1.50.5, which translates to 192.168.1.5. Agreed? Emmanuel, Santosh, Surya, Rohan, Palani? Now, what else do I need to do over here besides this? I need to allow the ACL. What do I do on the ACL? If anybody uses TCP, any source should be allowed to access, depending on what version of the iOS you're using, should be allowed to use for what? 80. Agreed? Now, that means I have allowed this PC to come into my network to access this guy only for web services. Perfect, this is good. It's a sense of security that I have. But once the packet comes in, what is the firewall really checking inside the packet? What part of the header is it checking? It's checking the source IP maybe? Destination IP? Ports, isn't that it? Anything on the application layer? Can this be a malicious packet and still make it through the firewall? Malicious means it's a valid web packet. It is coming into that particular server, but it might be harming the server. It might be running a malware against it. It might be running some type of attack against it. Do I know that? I don't. The firewall is a packet filter. It specifies what traffic is allowed to come into your device for what port number, basically based on layer 3, layer 4 characteristics. I'm talking about right now. Yes, there are advancements where you can integrate the ASA with your firepower. But I'm talking about right now with the normal 9.x without firepower integration. Even when you do the integration with firepower, it is another appliance or another capability that you're adding on to the firewall. It's not built in. Do you get my point? So that's where the IPS comes in. The function of the IPS allows you the ability to check an incoming packet against a well-known database of network attacks. So when the packet makes it through the IPS, through the firewall, it's a good packet, it's allowed. Now let me see if it's a malicious packet. How do I know it's a malicious packet or not? How does the IPS know it's a malicious packet or not? It has a database in which it has a snapshot or a pattern of a bad packet. So when the packet comes in, it says, let me see if this packet has the same characteristics as a bad packet because it has a signature of the bad packet. So it'll match it against the signature. If it matches that certain characteristic, say, hey, listen, this is an attack packet. It gives you the option of specifying the action. Okay, but that's entirely up to you. What action do you want to take on a particular signature? Do you just want to send an alert to the administrator? Hey, listen, this packet came in, it was trying this attack. Or do you want to actually take an action against it, like block it? Okay. This database contains a set of signatures which have the characteristics of well-known attacks. This database needs to be kept up to date for it to be effective. You guys understand that? If you don't do that, it's not going to be effective. Cisco will keep on updating their database. Right now, there's about 6,000 signatures they're up to. Make sense? Now, how does it work? IPS can be deployed in two different modes: promiscuous and inline. Okay? In promiscuous mode, the IPS device sits on the side analyzing traffic. This traffic is directed towards it by the switch using span. So what happens is the packet comes in from the edge device, maybe a router or firewall, it hits your internal firewall. In the middle, there's a switch. You copy the packet and send it to the IPS based on span. So you copy the traffic that is going to the firewall, send a copy towards the, like this. Let me just draw that out for you. There's a edge router connecting to the internet. Behind it is a switch, and then there on the switch you have your firewall, and there's the inside DMZ segment. What you do is you connect your IPS over here, and connect another interface over here for management. Packet comes in from the router, hits the switch. On the switch will forward it to the firewall based on the MAC address. In the meantime, you configure the switch for span, in which it will also send a copy of the packet to the IPS. It analyzes it. If it's a signature, it will notify the administrator. Optionally, if you want, you can have this management interface. The interface, it will have an IP on it. Let's say this is the inside network. So the management interface is also on the inside network. I have the ability to allow this IPS based on a signature firing. It can go over here dynamically, automatically, telnet in or SSH in, and block that traffic. So let's again go through the events. Packet came in from the router, hit the switch, copy sent towards the firewall, copy sent towards the IPS. IPS checks against the database, detects it's an attack, goes to the firewall, puts a block on the firewall. Or it could block it on the router as well. But what has happened in the meantime is the packet came into the firewall forwarded the packet to the server. At least some part of the attack was successful. Do you get my point? That's one mode. What is this mode called? It's called the promiscuous mode. Okay? You understand that? Is this good? From a security perspective, is this good? Not really, because some part of the attack still made it through. Right, guys? Emmanuel, Santosh, Surya, Ron, Palani? It's not that good because I don't understand how what. How some part of the attack made it through? Well, the packet came into your switch. What the switch does, the actual packet is destined for the firewall. Based on span, I just send a copy of the packet over here. The firewall, all it needs to do is check we just discussed that, layer 3, layer 4 characteristics. Whereas the IPS, in the meantime, it needs to go through an entire database of signatures. Let's say 6,000 signatures. While it's going through it, that packet has already made it through into your server. Once it discovers it, that, oh, it's an attack, it will go and put a block. But at that time, some of the packets would have made it through. Do you get that, Surya? Well, let's let's keep our judgments for a second. Yeah, it's not as secure, I should say. Why is it not secure? Because obviously some part of the attack made it through. But it does put a block, so the future attacks are blocked. Or even that particular attack, if it was a long attack, it got interrupted. Good? What's the other way to do it? This is called promiscuous mode. The other mode, which is called the inline mode. What is this? In this particular setup, what I do is I put the router, connects to the switch, switch connects up to the firewall. The firewall, in turn, connects up into the internal network. But what I do is I put the IPS smack in the middle. And then I put the inside segment. What happens in this case? I don't need any span because the packet is coming into the firewall. The firewall I manually put in what? The IPS in the middle. So all traffic will be forced through the IPS. It gets checked. Not a single packet, if it's not checked, will make it through over here. So once the check is okay, then the packet goes through. This is inline because the device itself is in the line of traffic. It needs to pass through the IPS to move forward. Whereas in the previous case, it was not in the line of traffic. Does that make sense? What, this one? IDS stands for detection services. This is preventing it, right? Promiscuous, no, not really, because I'm still preventing it because I did the block. I'm not just detecting it. It depends on the action that you take. It's still an IPS device. It has the capability of an IPS. It depends on how you actually set it up. If your action is to block, you're still getting prevention capabilities. IDS nowadays, no device just does detection. Even an IPS, if you're just logging it, you're not taking any action of blocking it, it's still a detection device because it's not preventing it, right? It depends on the action. What makes an IPS is prevention. Can I prevent it or not? If I'm just logging it, even if it's called the IPS, it's still a detection device. You understand that? Detection is I just detect the attack, I log it, but I don't take any action on it. So it's just a concept. So an IPS device is an IPS device if it prevents. So this is good. Now, not a single packet goes through unless it is a valid packet. Agreed? This is good, that's bad. But you need to also understand the drawback of doing this. You have just induced a guaranteed delay. You have induced a latency in your network. Have you slowed down the things over here? Absolutely. The packet that would have gone from the firewall directly into your servers now is getting checked before it's sent across. Is there a delay? Is there a performance hit? Absolutely is. Was there any delay in promiscuous mode? No. So is that an advantage of promiscuous mode? Maybe you're not really concerned about security as much. Yeah, you do want to have security, but you also don't want to have the performance impacted. So if performance is more important to you or as important as security, maybe promiscuous mode is good enough because maybe some part of the attack would make it through, but you would still block it. Do you understand what I'm trying to get to you to think? It's not about what is good or what is bad. From a design perspective, you need to take a look at your SLAs, your requirements, and based on that, you implement a particular technology. So if your requirement is performance with security, then promiscuous is better because yes, it does provide security. It does not impact your performance at all. Why? In promiscuous, what had happened was this. The packet came in over here. Packet came into the switch forwarded a copy of the packet to the firewall, a copy to the IPS. While the firewall is processing it, there's no IPS in promiscuous mode over here. So it would have gone directly to the server. In the meantime, parallelly, the IDS or IPS was processing it. But there was no induction of any type of latency in the network. Do you get my point? So promiscuous mode is still good. It's not bad. But you need to take a look at what your company's requirements are and do it based on that. Do you understand where I'm coming from? So it's not always a good thing or a bad thing. You need to take a look at it and analyze it based on that. Good? Did we enable IPS on the firewall inside interface with span on switch or IPS as layer 3 hop? IPS is never a layer 3 hop. It's always a layer 2 device. So IPS, when it was in the inside, it's a layer 2 device. I was going to get to that. We haven't gotten to that point yet because we haven't gotten that deep yet. IPS over here is a layer 2 device, like a transparent firewall. Remember we did transparent firewall? It's like a transparent firewall. This is the same IP subnet. And you isolate the two segments by using two different VLANs. I'll use VLAN 10 over here, VLAN 20 over here. So whatever packet comes through from the firewall hits the IPS. This is a layer 2 interface. I don't need IPS, span for this. So the packet comes in, it's in VLAN 10, it's the IPS. If it's okay, it'll go off this particular interface. Good. The IPS, the device itself, comes with 4 ports, or depends on the appliance. I shouldn't say 4 ports. Let's say it comes 3 ports, 4 ports, depends on whatever appliance that you have. Let's take an example. I have one interface which is dedicated to be the management interface, the only layer 3 interface on it. This is the only one that can be assigned an IP address. The rest of the interfaces are all monitoring interface, layer 2 interfaces. How will the IPS stop the second packet? Remember I showed you that it goes in and puts a block on the firewall. Let's say, let me go through this. I'll come back to your question, Polani, 1 second. So let's say you have this. So this is your IPS. What you have the ability to do is you can, on this IPS, you have the management interface, which is used to configure it. Then you have 4 interfaces over here. What I have the ability to do on the same network, I can put IPS over here to connect these 2 segments. This is VLAN 10 and VLAN 20, let's say. I'll put this port into VLAN 20 or 10 and put this port into VLAN 20. I'll use the other 2 ports, put them into what? So I can have the same device connect what? Multiple VLANs to each other. So I'm not restricted, so I can have the same, it's the same IPS in both places, but it's different interfaces. This is what an IPS looks like. A management interface that's just strictly for management. And then I have layer 2 interfaces. So sometimes you might see multiple IPSs on your diagram, but physically it's the same one. For example, over here, the diagram that I was drawing earlier on. How many IPSs do you see over here? 1, 2, and 3. Just to let you know, I'm going to use this for my management interface to configure it. This is an IPS that connects VLAN 10 to VLAN 20. Same IP subnet on both sides. It's a layer 2 device. Same thing over here. VLAN 30 connects to VLAN 40. Same IP subnet on both sides. Do you remember when we did transparent firewall? Same type of setup, right? Emmanuel, Santosh, Surya, Rohan, Polani, you guys good with this? Polani, Santosh. So when you see these multiple IPSs, don't assume that you have 3 IPSs. One of them is just the management. It's just depiction of the same device in different parts of the network. Now, coming back to your question, Palani, let's say I had promiscuous mode. So I have a switch over here, and my IPS is connected over here using a L2 interface. He does span. First packet comes in, hits my, switch. Switch sends a copy over here, sends a copy over here. Every packet is going to do that. In the meantime, I don't have this IPS over here. It goes in and hits my internal server. In the meantime, the IPS using its management interface would telnet into the firewall and put a block. On the firewall, it uses a command called shun to put a block. On the, on a router, it uses an ACL. We'll get to that as well. Do you understand this first, Palani? I'm answering your first question first. Got it? So that's how I do it. IPS actually logs in. It doesn't advise. It actually does the log. It's like an administrator going in and putting the command in. You need to configure the IPS to log into the firewall or the router, but it does it automatically. It doesn't advise it. It does it. Based on the attacker address. Means it actually implements a command on the firewall. So it's like an administrator logging in and typing the command. The only difference is the IPS does it automatically. Either using Telnet or SSH. Good? Clear. Now the next thing creates a block, basically, yeah. Create a block means create a block on the firewall. It uses a command called shun. It says shun x.x.x.x means block x.x.x.x. It puts that command in. On the router, it creates an ACL. It says deny IP x.x.x.x from coming in. That's what I mean, creates a block. Make sense or no? So I'm actually logging in and doing it. We'll do that over here as well, so you'll see it. On the firewall, it does shun. Shun is a command. On the router, it does an ACL. Shun is a command on the firewall that says block, means block. Okay. Yes, that's exactly what sends is too wrong. It's wrong. It's a wrong word. Send means I'll send it to him. Versus, think about an administrator, invisible administrator logging in and typing that command in for it. So it actually telnets in and says, I want to create this ACL. It actually creates the ACL on the router. So you need to give the IPS the username password so it can log into the router or the firewall to do these type of things for blocking. All right. Now the next thing I want to talk about is this same setup. How many IPSs in layer 2 mode do you see over here? This is the management. Forget this one. This is IPS in L2 mode. This is IPS in L2 mode. Okay. Now let's say my firewall, my IPS has a management interface. Let's say it only has 3 interfaces. This model only had 3 interfaces. So I put this interface into what? As an access port on the switch in VLAN 20. I put this port over here in VLAN 10. So the first port and the second port are gone. This is gone, this is gone. How many ports do I have now? Emmanuel, Santosh, Surya, Rohan, Polani, how many ports do I have left? 1. Correct? Now, I have 1 port, but I need 2. I need one for VLAN 30 and one for VLAN 40. That's where I do what is known as a VLAN pair. On the switch, I'll trunk that third port because you understand this IPS will be connected to a switch. On the switch, I'll trunk that port using .1q. When I trunk a port, the switch does not remove the VLAN tag. It sends a packet to the IPS with a VLAN tag of 30 or 40. On the IPS, I'll say any packet that is coming in with a VLAN tag of 30, check it. If it's okay, replace the tag 30 with VLAN 40 tag and send it back. This is called an IPS on a stick. So physically, it's like this. IPS using a single port connected to the switch. Switch is trunking it. This trunk will be allowing what VLANs to cross over? 30 and 40. On the IPS, I say if packet 30 comes in off this port with a VLAN tag of 30, check it. If it's okay, I will change the tag to 40 and send it back. When I send the packet back with the VLAN 40, it goes into VLAN 40 ports. This is known as a VLAN pair. When I have physical interfaces allocated, I'm linking up interface 1 with interface 2. It's called an interface pair. So we'll take a look at a VLAN pair as well as an interface pair. Interface pair, which allows me to dedicate an interface for a particular VLAN. In that case, on the IPS, I would not, on the switch, I would not trunk it. I would put it into a particular VLAN, like an access port. Like a router on a stick or a firewall on a stick, allows me the ability to have a single port carry multiple VLANs so I can segregate it. And that's what the IPS is doing in a VLAN pair mode. We'll do both. What I'm going to do over here is I'm going to use my first port on my IPS over here. I have this as, let's say, gig 0/0, and this is going to be gig 0/1. I'm only left with one port over here, which is gig 0/2. Gig 0/2, I'm going to create a VLAN pair for you guys. And then I have the management interface over here. You guys good with that? You understand what I'm trying to accomplish over here? And once that's done, I'm going to show you how to configure the IPS in inline interface pair mode as well as VLAN pair mode. I'll also do a block so that I can also block it over here so that you can see the blocking aspect as well. Questions before I start configuring the IPS? You guys okay with this? Emmanuel, Santosh, Rohan, Polani, Surya, all good? Let me start configuring this. How many routers do you see over here? I need to pull those number of routers. See 1, 2, 3, 4, 5, and 6. I need one firewall and IPS. I'll configure all of them on one switch. Let's do that. First thing that I'll do is I'll copy or paste 6 devices over here, 6 routers. These are all my routers. And some of the routers have multiple interfaces. How many of them have multiple interfaces? 4, 5, and 6 will have two interfaces each. And then I have the firewall. Let's take a firewall over here. And a cloud, which is going to be my IPS. Change the symbol, make it like this. It's my IPS, and I'll take an ether switch router so that I can do VLANs over here. Now my connections. R1 F00 connects to switch 1 port 1, 1 on 1, 2 on 2, 3 on 3, 4 on 4. I need to remember that, or I'll show you where to see it, because I need to assign VLANs to them later on. 5 on 5, 6 on 6. For right now, I'm just doing one interface on the routers, so 1, 2, 3, 4, 5, 6. On the IPS, I have 4 interfaces. I need to configure them first. The first one is my management interface, IPS management, add, and then I have 3 VMware interfaces, 9, 10, and 11, which are my 9. VMnet 9 is my G00, VMnet 10 is G01, and VMnet 11 is G02. 3 LAN interfaces I have. Done. Now let's go over here again. Go manual. We'll do 10. I need 3 interfaces on the firewall. 10, this is 00 goes on 10. 01 goes on 11. 02 goes on, let's say 12. Good. IPS management, first interface is my management, the top one. I'll put it on F10. That's my first switching port. Okay. I'm going to put the 3 interfaces, G00 as 13, G01 as 14, and G02 as 15. I'll show you this later on in a second. Now I also need to connect my 3 routers to each other over here. You take a look. So router 4 has 2 interfaces, one here and one here. So second interface, he has 2 interfaces, he has 2 interfaces. So I'll put 4. So I'll go to 4, 0, 1, the second interface. I'll connect it to 7. 5, second interface will be on 8, and 6, second interface will be on 9. All of them are populated right now. Let's launch it. By the way, you can see all that over here. So now first thing I'll do is create my VLANs and do my port assignments. Everything can be seen over here. For example, router 1 F00 is on port 1. 2 is on 2, 3 is on 3, 4 is on 4, 5 is on 5, 6 on 6. 1, 7 connects to 4 F01, 8 is on 5 F01, 9 is on 601. These are your firewall. E0 is 10, E1 is 11, E2 is 12. And these are my IPS sensing ports, 13, 14, and 15. This is my IPS management port. Now, first thing that I need to do is look at my topology and start creating my VLANs and then assigning ports to it. How many VLANs do I have total? 10, 20, 30, 40, 50. So 10 to 50, and then I have 46 and 56. So I have 7 VLANs. Let's go to my switch because that's the one that we'll be configuring over here up front. On the Ether switch router that I have, the 3725, I'm using the Ether switch module. With the router, it has a speed and duplex mismatch. So all the router ports, I need to set the speed manually. I'll do that in a second. This is my switch. All right. First things first, VLANs 10, 20, 30, 40, 50, 46, and 56. (10, 20, 30, 40, 46, 50, and 56). My VLANs are created. If you remember, my router ports are 1 through 9. So these ports, I'm going to set the speed manually. Range fast Ethernet 1/1 through 9. Speed 100, duplex full. Because the routers have an issue with speed and duplex when you use an Ether switch module. Now, let's take a look at this diagram and start assigning ports. We'll start at the top. I'm going to use F01s over here. F0/1 connects up to F0/1. All right, that'll be 56. So F01 of R5 and R6 should be in the same VLAN. F01 of R5, F01 of R6. If you look at your topology over here, 01 of R5 and 01 of R6, 8 and 9 should be in this VLAN. 56. Let's do the switch side first. We'll do the router side later. Let's just do the VLAN assignment first. So F00, F01 and F01 of 5 and 6, which is 8 and 9, should be in the same VLAN 56. So I'll say interface range, fast Ethernet 1/8, 9, switch port mode access, switch port access VLAN 56. You guys understand what I did? I just configured these 2 ports to be part of VLAN 56. We'll use these 2 ports now as F00. And this on the firewall is E0. This is E2. And this is E1. Let me just put everything up and then we can F00. Start assigning it based on that. IPS I'm going to leave aside, so we'll do IPS at the end. It's F00, F00, all right. So this VLAN is done over here. What I've done so far is this guy. These 2 ports are in VLAN 56. Let's do this one. R6 to R4. F00, F00 of 4 and 6 should be in VLAN 56. This is port 4, this is port 6. So port 4 and port 6 should be in VLAN 46. Similar type of thing. 1/4 and 1/6. 46. Oops. Sorry. So this part is done as well. Let's just check. So I have ports in 46, 4 and 6, and 8 and 9. So these two VLANs are taken care of now. The next one we'll do is this one, R5F00 and E0 of the firewall. This is port 10. This is port 5. Because if you remember, I went 1, 2, 3, 4, 5, 6 for F00 in order, and for the firewall I said 10 for E0, 11 for E1, 12 for E2. So that's how I'm remembering it. So R5 and 10. So which is, if I go into the range, 5 and 10, mode access, VLAN 50. So another two taken care of. So 46, 56, and 50 are done. So the top portion is done. Now let's take a look at the VLAN 30. I'm not going to do anything with the IPS right now. So just the firewall port. E2 should be in 30. E1 should be in 20. So E2 and 30. E2 is 12. That is E2 is in 12 is in 30. And E11, I believe, is in 20. Just to make sure. 11 is in 20. Make sure they're gone. 11 and 12 are taken care of. So now, forget the IPS, as I said. We'll do that as part of the IPS config. This guy is done. This guy is done. This guy is done. This guy is done. Now on the VLAN side, IPS management I will do because I need management capabilities. So this is port F1/0. This is 1/1. And this is 1/7, I believe. We'll check that. R4F01. So 1/1 and 10 and 1/1 for sure. And then 1/7. The PC is directly connected, so it's okay. So all I need to check is R4 1/0 is 7. So 1010, that's the management. 11, which is router 1, these two, and then this guy over here, R4 F01, which is 7. 10, 11, and 17. 1/0-1, 10 and 1, and 1/7. VLAN 10, and that should take care of everything except for the IPS. Now forget the IPS right now. Let's configure the routing on these. This is my outside network. This portion over here is my outside network. Let's configure routing over here so that these guys, I don't need to worry about reachability. Okay? So I'll do EIGRP on them and connect them up. So let's start with R4. R4 connects to 6. So start with R4 over here. Outside interface is 46.4. We'll keep the IP address based on their router numbers. F01 is 10, 11, 11, 0, or sorry, 4. Okay. And for reachability on the outside, so that I don't need to worry about reachability, I'll just run a routing protocol. Otherwise, a default gateway would have been okay. 4 is done. The only thing is on the routers again, I need to set the speed and duplex, otherwise they're going to complain. Now they're not. 4 is done. Let's do 5 now. This guy's done. 5 is F00 towards 50, F01 towards 56. .5. My routing. Done. And then the third router is router 6 over here, which is 56 on F01, 46 on F00. Let's do that one. All right, so that is reachable. The next device I want to do over here and knock it out is the firewall, the 3 interfaces, and run EIGRP on the outside only. Because inside it's just 10 and 192.168. So on the outside, let's do the firewall now. It's right over here. Interface E0. .10 E1, it's the 10.11.11.10 network. Name if inside. And the third network is 192.168. I'll also enable telnet over here because I'm going to test it later on. 10.11.11.0 on the inside network. All right, brilliant. So router EIGRP 100, no auto. Network 50, I want to run EIGRP on the outside interface. Show IP route, show route. There you go. My outside network is running properly, no problems over there. Now the other devices that I have on my topology, router 1 is on the inside VLAN, VLAN 10, 10.11.11, we'll say .1, my default gateway, I'll point it to my firewall. Router 1, only one interface I have. All right, I'll just point a default gateway over here. I won't be able to ping it yet. The reason I can't ping it is because I have this IPS in the middle. But I should be able to ping R4, 10.11.11.4. So let's check that. Give it some time for spanning tree, but there you go. 10.1 and 10.4. These guys over here are communicating to each other. And we also already have established that the outside interfaces are all talking to each other. I won't be able to set this up yet until I set the IPS. And the last thing that I want to do is this routing over here between R2 and R3. They won't be able to go across the IPS because there's an IPS unconfigured, but 2 and 3 should be able to talk to each other. They're in VLAN 40. So let's check that. (192.168.1.2). All right. Default gateway, we'll set it to the firewall, which is 1.10, and we'll do router 3. Oops. One dot 2. Done. So these guys are talking to each other as well. So my network is set up right now. Now let's take a look at how to configure the IPS. I'll launch my IPS over here. It's a blank IPS snapshot. Let it come up. The username is Cisco, and on my IPS it's called Cisco IPS 123. Oops, what happened? Cisco IPS 123, I'm in. The first thing that you do over here is run setup. The host name, let's call it IPS. The IP address is in this format. I don't need to change it, but if I did, this is the format that you can see over here. The format is like this: IP address / mask, comma, the default gateway. So let's say I want to keep a different IP address. I'll say 10.11.11.11 is my IPS address. How do I set it? 10.11.11.11/24. That's your IP address, comma, 10.11.11.10, which is the firewall as the default gateway. Modify current access list. This specifies which device can remotely manage it. So yes, I do want to modify it. It right now says 10.11.11.0 can modify it, right? I want to change it. I want to delete it. So 1 to delete, enter, permit. I want to only allow 10.11.11.99/32 to modify it. So that's the administration workstation that can come in and configure the IPS. So I'm controlling who can manage the IPS remotely. So only the device that has an IP address of 10.11.11.99 will be able to manage it. So I need to set my IP address to 10.11.11.99. Once I'm done, press enter, take defaults for the rest. Save the config and you're done. The rest of the config you do is from your graphical interface. So the first thing that I'll do is my IPS management interface, which is this guy on my PC. I need to set the IP address of this guy to 10.11.11 .99. Otherwise, it will not be able to connect up. So once I do that, now I can open my browser up. https://10.11.11.11. Continue to this website. Run IDM. Allow. Always allow. The username is Cisco, password is Cisco, IPS 123. And this is my graphical interface of the IPS. I want you guys to notice the interface status. How many interfaces do I see over here? I see the management interface, which is up. All the other interfaces are down. You guys okay with this so far? Good? Clear? All right, so now my objective over here is to set this topology up so it works. Everything is set up. Now I need to bring my IPS up. As we agreed upon earlier on, I'm going to set this IPS to connect VLAN 10 and 20 to each other. I have two interfaces on IPS I'm going to use for this. This is called an interface pair. I'm going to connect G00 to G01. G00 should be in VLAN 10. G01 should be in VLAN 20. These are access ports. Because an interface pair, it's an access port. How do I configure an interface pair to bring it up? Let's take a look. The steps. Let me complete this in line mode. The IPS device sits in the line of traffic. Any traffic, all traffic will be inspected before it is allowed to go through. So the configuration now, configuring IPS and inline interface pair mode. Step 1. Assign the interfaces to the appropriate VLANs on the switch as access ports. So on the switch, I'm going to do interface. If you guys remember, I used 13, 14, and 15. 13 was G00, 14 was G01, 15 was G02. So I'll do switch port, access VLAN. Well, we need server power. Yeah, but if you're doing the individual labs, you just turn one of them on at the same time. You don't do all of them at the same time. So switch port access VLAN. 13 is G00. G00 we said was going to be part of this particular VLAN 20. Let's write that down over here. Similarly, the other port 14. Access VLAN 10. You understand what I did? I assign one interface in one VLAN, the other in the other one, just like you do in transparent firewall. Copy it, go to the switch, paste it. So the switch side is done. Second step, in the IPS, bring the interface up. Where do you do it? I'll just write that down for you. Configuration, interfaces, interface. That's where you bring it up. Let's understand that. Where is that? Configuration, interfaces, interfaces. I need to bring these two ports up. Which two ports? G00 and G01. They're not enabled right now. Enable them and apply them. So they're up now. Clear? Done? Step 2. Step 3. Create an interface pair to link G00 to G01. Basically, what I'm saying over here is when I link them together, any traffic that comes from G00, check it against the database. If it's okay, send it to G01. So you're basically linking the two to each other, saying that traffic from G01, check, G02 is the destination. If it comes from G00, check, if it's okay, send it to G01. So I'm linking them together. That's the interface pair that you create. Where do you do it? Configuration, interfaces, interface pair. Let's check again. Where is that? Configuration, interfaces, interface pair. I'll click on add, give it a name, whatever you want to call it. Inside, for example, just a name. G00, G01. Didn't I select it? Okay. Notice G00, G01 are selected. That means they're linked to each other. One interface can be only in one pair. Apply it. My pair is created. Last step. Assign the pair to a virtual sensor which is linked to the signature definition database. So this is where I'm going to assign it to the database. It's under configuration, the policies, IPS policies. I'll just check to make sure that's the right thing. Configuration, policies, IPS policies. Notice there's a virtual sensor called VS0, which is checking against SIG0. By default, there's only one signature database called SIG0. This contains all your signatures. I'm going to assign the interface pair over here. How? Edit. Remember that inside that I created that linked up what? G00 and G01. Highlight it. Click OK. It is now over here. Don't forget you need to apply it. Now I have connected up this. It's going to be checked against the signature database 0, which has, if I click on all signatures under signature 0, it will show you all the signature it has. Let it fire up. This particular version right now has 5,500 signatures. All right. At this time, if I go to router 1 right now, I should be able to ping 10, 11, 11, 10. Who's 10, 11, 11, 10? the firewall. So I am going through, right now, I'm going through here. The only way I can go from VLAN 10 to VLAN 20 is through the IPS. Ping is a OK packet, send it across. Or for that matter, I can telnet in. Why do we need to create an interface pair? Without interface pair, it will not work. I need to specify which two interfaces which two VLANs am I linking up? So if you don't create a pair, it doesn't know where the traffic comes from, where does it need to go. So it's always done based on a pair. IPS sits in the middle of two VLANs. You need to specify which those two VLANs are. You're doing it either by interface, or if you use a single interface, then you would need to specify it based on the VLAN pair. So you have to, it's a requirement to create the interfaces that are linking the two VLANs to each other. You need to understand the whole purpose of an IPS in inline mode is to sit in the middle of two segments. What are the two segments? You can either specify the two segments by assigning one interface to one VLAN, the other interface to the other VLAN, or you can create a VLAN pair, which I'm going to do next. So yes, it is a requirement, because my objective is to connect two different segments. Which two segments? Okay. And do you remember I put this interface in 10, this interface in 20? That's how I specified the segments. So right now I have connected the two to each other. So I can now telnet in over here. Let me show you the same thing before and after on the other side. So I'll say telnet 192.168 through the DMZ. It's not going to work. On the DMZ I have router 2. I should not be able to telnet into 1.10. Why not? Because I have the IPS in the middle. I'm in two different VLANs. Or for that matter, I would not be able to ping it. Okay? You guys okay with that? It's a bidirectional interface. Absolutely correct. It's going to check whether the packet is a bad packet, either in to out or out to in. So it's not working right now between what? R2, R3 towards the firewall, because there's an IPS in two different VLANs. But I'm only left with one interface. How do I do two interfaces over here? That's where I was talking about. You need to create a VLAN pair. How do I create a VLAN pair? That IPS interface that I have, the third interface over here, one of these interfaces over here, the last one, what am I going to do with the last one? I am going to set the last interface over here as a trunk. Trunk allows multiple VLANs. I'm only going to allow VLANs 30 and 40 because my objective is to connect VLAN 30 to VLAN 40. Okay, so what are the steps to create a VLAN pair if you're running out of interfaces? This was for your IPS in interface pair. If you don't have enough interfaces, I will create a VLAN pair. How do I create a VLAN pair? Assign the interfaces, configure the switch interface connecting towards this IPS interface as a trunk and allow the appropriate VLANs. So on the switch, that port is 15 for me, the last one. And I am going to create that as a trunk. How do I do that? Switch port trunk encapsulation .1q. Switch port mode trunk. Switch port trunk allowed VLAN 30, 40. Because those are the two ports that I want to use up. Copy it, go to the switch. That's 15. on this particular type of setup, I need to allow these other VLANs as well. This is because of the Ethernet switch module. Otherwise, you don't need to. The default VLANs. So show interface trunk, you should have that trunk interface F0/15. What do I do on the IPS? Bring the interface up. In my case, one interface. Which one? So I've done that. So again, configuration, interfaces, interface, bring G02 up, enable it, apply it. Next, I'll create a VLAN pair. In the VLAN pair, when I go to create it, add, G02 is the interface. I need to give it a sub-interface ID, any number, doesn't matter. VLANs that I want to link up, 30 and 40, doesn't matter the order. Click OK and apply. I've done that. So let's do that over here as well. Put that in. Second thing, create a, not an interface pair, we'll create a VLAN pair to link VLANs 30 and 40. This is under VLAN pair, and assign the pair to the virtual sensor which is linked to the signature database, same place. So once this is created, I'll go to policies, IPS policies. Now I have two choices over here. I can either assign it to the same database. That means the same signatures that I enable for one will be enabled for the other one. If I want them to have different policies, I have the ability over here to create a different signature database. Let's call it SIG1. The other one is SIG0. This is a brand new one. So it's going to be a brand new database. Once I create that, here I can create a separate virtual sensor. It'll say VS1, assign it, have it use signature 1. So now I have two different databases. If I want to have different type of signatures enabled for what? Different checks to be done on the DMZ, different checks to be done on the inside. I have the capability of doing that. This is okay, it's ignored. Just ignore it, it should be good. So now I have two different databases. Now keep in mind, if I want to do anything with SIG0, if I do anything with SIG0, any signatures that I change, they're only going to affect my inside network. If I change anything in SIG1, it's only going to affect my DMZ network. If I wanted the same signatures for both, then I would go ahead and create, I did not need to create a separate signature database. I could check everything based on the same virtual sensor. You get my point? So the only reason I did that is if I want to have what? Two different policies for the two different segments. You guys okay with that? Emmanuel, Santosh, Surya, Rohan, Palani, all good? All right. Now that I've done this, my telnet, my pings from R2 should work. This is not a good sign. Let me check my IPs. This looks good. Something probably do with the firewall. Let me check my config real quick over here. G01, SIG1, 30, and 40. All right, let's check the switch. Just checking the ports. 12 is in 30. Oh yeah, 2 and 3 are in VLAN 1, so I need to put them into VLAN 40. I left them in VLAN 1, so interface range, fast Ethernet 1/2, 2.3, switch port mode, access. Because I'm connecting 30 and 40 to each other. 2 and 3 were not in. 40 there and 1. Now it should work. Give it some time for your STP to kick in, but then it will work. STP takes about 30 seconds for that listening, learning. There you go, and my telnet will work as well. Good. You guys okay with creating your VLAN pair and the interface pair? Any questions on that? Good. So in terms of what we needed to cover, we've done this already. Router switch we did yesterday. IPS. How far are we at? Let's take a look. Overview done. Basic initialization of IPS. This was the CLI portion. Done. Inline interface pair mode. Done. Inline VLAN pair mode. Done. The next thing that we need to take a look at is your signature tuning, custom signatures, and sensor tuning. Let's take a look at signature tuning first. Yeah, we can do a simple attack. Let me tell you what an attack is. What is deemed as an attack? Attack on an IPS is if a packet comes in and the packet is matched against a particular pattern. We can send a packet with a certain pattern on which we have a signature enabled. Ping is a signature. Do you understand what I'm saying? When you send a ping, if the ping signature is enabled, it's something that you can take an action on. Why is ping an attack? Ping is known as an attack which falls under the category of a reconnaissance attack. Ping scopes the network up. What do I mean by that? I ping 15 devices, only one of them responds back. So how's that an attack? The response device that has responded back to me. Now the rest of the attacks I'm going to form against that IP. So it's like doing spying. Spying doesn't destroy a particular location, but it finds out this is a sensitive location. So that's exactly what I can do with ICMP. Let's take a look at a couple of signatures. We'll also do some custom signatures. First thing that I want to do is I want to take an action on ICMP. It is part of your database. Now, the way you go and figure that database out, I'm going to do it on SIG0. If you remember, SIG0 is on the inside. You can either go into different type of signatures by looking at the categories, or you can go to all signatures. All signatures, as the name suggests, shows you all the signatures in this database. Now you can search based on signature IDs, which is the number assigned to that particular signature, or you can search based on name. This is your filter. I can look for an ICMP echo signature. the signature echo reply, echo request is retired. So the first thing that I'll do is unretire it. Make it an active signature. Once it's activated, I will enable it. Right now, the only signature action it has is alert. Do you see that? That's the signature action I'm taking. But I can take a more drastic action. So I'll apply it. So my echo request signature is enabled. Now, the good thing about this is it also allows you the ability, if you want, to see which signatures have you changed. Changing the signature is known as tuning it. So I can click on my filter, and one of the options is type. Under type, one of the options is tuned. So this is the only signature that I have changed. All the other signatures that I have, let me just show you all the signatures, by the way. You have, although you have 5,500 signatures, out of those, only 1,575 have been enabled. So it's only checking the ones that have been enabled, the ones with the check boxes over here. But ICMP now is because I tuned it. Tuned means what? Changed it. Let's check that. I did it on the 6.0, which affects the inside network. So to check that, I'll go to switch to router 1 and ping 10.11.11.10. It went there. Why? My action was just to alert. So where does it do the alerting then? I can go in under monitoring. One of the options is events. Show past events in the past 1 hour. View. And you'll notice that the echo request had come in. If you check on the details over here, it will show you the actual packet. This echo request signature was invoked because an attacker 10.11.11.1 tried to ping 10.11.11.10. Does that make sense? You guys good with this? So this is just telling you that the attack happened. Now, let's say I don't want pings coming in. I think ping is a reconnaissance attack and I want to block it. Well, how do I block it? I go back into configurations. Again, easy way to do it is by looking at what? Type tuned. Here, if I right click on it, one of the options is edit actions. Click on it. In terms of alerting, the only one that is on is produce alert. I also have one deny action column. In the deny action column, I can deny the packet. Now, what does deny packet do? It only takes action on the current packet. What do I mean by that? The packet that's coming in, I'll block that packet. I'll deny the packet. But I will not think that this guy is a bad guy for the future. So I'm not going to take any future actions against it. I'm just going to deny the packet, drop the packet, don't let ping work, but I will not say this is a bad guy, I should block him completely. Deny packet only affects the current packet. So I'll click OK and apply. Now type tuned, again filter. Now my action is not only to alert but also to deny the packet. Let's take a look now. Will my ping work now? Should it? Should the ping work right now? It won't, because my action is to deny the packet. Okay, but my telnet will, because telnet is not denied. It does that automatically. You don't need to do the Wireshark portion of it. You can see the packet itself over here. If I look at the monitoring over here, view, any of the packet, you can do details and it shows you the packet. Now, if you want more detailed information about the packet, there's an option under configuration which says the action is produce verbose alert. Or you can log the packets, not inside your Wireshark. They'll be shown to you inside your, what do you call it? The monitoring utility over here, but you can look at the packet. Verbose and logging will give you more details about that particular packet. Cool? Now, there's another action over there which is a little bit more drastic. I'm getting to that. So if you take a look at this over here, it's not just one. There's a bunch of different other actions that you have. One is deny packet. The other one is connection, deny the connection inline. Deny the connection inline. It will not only drop the current packet, drops current packet, the one that offended it, plus deny connection inline not only denies that particular packet, but also denies any future packets from this guy to this guy for that particular service. So he will no longer be able to ping him again. But it's for a connection. It's not for ICMP. It would be for TCP-based connections. So if he was doing telnet and telnet had triggered an attack with a deny connection inline, it would say the A to B for, let's say, telnet is not allowed. Or actually, take that back. This one says A is not allowed to telnet to anybody. A is blocked from telnetting in. So A will be completely blocked from doing what? Telnetting in to anybody else. Because the packet was based on telnet. Versus deny attacker victim pair means A cannot do anything to B. Attacker and victim. Do you get my point? So A cannot do anything with B. If he pinged it, yeah, ping will be blocked, but also from A to B for any other thing will also be blocked. But only from A to B. A can still go to what? C. This is okay, this is wrong. This is in the attacker victim because I'm taking what into consideration? The attacker and the victim in this. Attacker service pair inline, another variation which says A to B for telnet. Notice this was A to anybody for telnet, A to B for telnet. It's a pair. A to B for telnet versus A to anybody for telnet. So it's specifics that it's blocking. And the last one, deny attacker inline. That is the most drastic. A to anyone for anything. Just completely block this attacker. Nothing. He will not be able to connect to anybody. Do you get my point? So there's different levels of blocks that you do. Now, where does it do the block and how long does it keep the block? If any of these actions take place, whether it's for a connection, for attacker victim pair, attacker service pair inline, or attacker inline, this is done for consequent packets for 60 minutes by default. All right, it will put the block for the next 60 minutes. These things will take place, whichever one you've elected. So for example, I'll do the most drastic one. I'll say if this guy does this attack, deny this guy to communicate to anybody on my network, block him completely. Deny packet didn't do that. Remember, I did ping, and after that, no future consequences, he could telnet in. But now if he does a ping, which is a little bit more drastic for him, but I just want to show you, he will not be able to telnet or do anything from that point on. Deny connection and deny attacker victim pair. I'll explain that. Let me show you this, the attacker first. We'll come back to that. So now I'll do a ping. The ping will be blocked, obviously. But remember, after the ping getting blocked, I could still do what? I could still do telnet. But now I can't, because I'm completely blocked. A to any is blocked. So if I go over here to monitoring, action over here would be now denied attacker. And you can see the list under configuration, sensor management, denied attackers. 10.11.11.1 attacker IP is gone. For how long? What did I tell you the default is? How long is the block there for? 60 minutes. You can change it. I'll show you that. So this is blocked for 60 minutes. Okay. I can manually delete it if he's a friend of mine, it's okay. So I can clear the list. Or wait for what? 60 minutes. Where's that 60 minutes? If you go to policies, under policies, go to IPS policies. Under the general category, the deny attacker duration is 3,600 seconds, which is 60 minutes. Good. Now, question was asked. Let me answer that. Can you explain the difference between deny connection and deny attacker victim pair? Deny connection will block the attacker for that particular port. A to any for telnet. When it's a pair, it's always from one to the other. So that is A to B for 23. This is connection. This is attacker victim pair. Okay. Okay, attacker victim pair is not just this, sorry. Attacker and victim pair, I thought you were talking about the service pair. That is A to B for anything. That's what you wrote. And your service pair inline is A to B for 23. B is the victim. Good. These are your different actions that you have. You guys okay with this? All good? This is called sensor tuning. Tuning because I am changing an existing signature's characteristics. I'm changing an existing signature's characteristics, and that's what I did over here. So that was this part. I can also create what is known as a custom signature. What's a custom signature? I will create the characteristics from scratch. Very powerful. Let's say somebody's attacking you and you run Wireshark and you figure out that this guy who's attacking me is always sending me a packet based on a port number TCP, let's say 8888, and it's sending me inside this TCP 8888, it's sending this string, you are a fool. And it blocks my system or does some malicious stuff with you. This is not a well-known, what do you call it, signature. It's somebody that's just fooling around with you. Cisco does not have any signatures for it. You want to create your own. Can you do that? Absolutely. Let's take a look. I'm not going to do 8888. I'm going to use Telnet so I can test it. Okay, clear? This is called a custom signature because you are creating it. Agreed? So how do I do it? This time around, I'm going to use this database, SIG1, just so that you guys can see it's for a signature, different signature database. SIG1 only affects what? 32, 40. This one, the one that I just did was for SIG0, which only affects 10 and 20. Remember the different virtual sensors that we have created. So right now, if I go to, although R1 cannot ping the firewall, R2, which is on the DMZ, has no problems. Good? Clear? So let's do that over here. Do that you are a fool signature. Where is this? Right over here. First thing, pick the right signature database. In my case, SIG1. Okay, done. There's an option over here called the signature wizard. Click on it. Click yes. I'm going to do it based on a string because I'm looking for a character. TCP because I'm going to test it with Telnet. You could have done it with ICMP. You could do it for a UDP packet as well. Custom signatures start with the number 60,000. It's up to you. You can use a different number as long as it's not being used. I'll call this signature fool. It's just a name. What action do you want to do? I want to block this guy completely. Deny attacker. What's a regular expression that I want to match? You are a fool. Service port 23. Over here, you would put whatever port you want to use. Click next, next, and finish. So all I did over there, I said if the string you are a fool is done in a telnet packet, it should be deemed as a attack packet. Can you see how powerful this can be? All you got to do is run your Wireshark, analyze the attack packet, figure out a certain characteristic that is in all the packets, and based on that, you can actually block the attacks. You guys understand that? Let's see if it works. Let's go to router 2, and we'll telnet into 10. Log in. You are a fool. Can't type in, I'm blocked. The reason foo didn't show up, the way telnet works, it sends a L to the other side before it echoes it back on the screen. So it sends a L to the destination, and the destination sends it back on the screen. As soon as I send the L, it blocked. I'm blocked. You can check that over here. If I went to sensor management, this guy is blocked. Now take a look at the event for it. It actually shows you the packet. View. The full signature has kicked in, and this is what you were talking about that you wanted to see. This is the actual packet that has gone through user access verification. I put the password, I tapped in enable. The password that I typed in was Cisco over here, shows you that as well. And then I typed in you are a fool. And who did it? This guy did it from this source port to this destination port. And he's blocked now. Do you guys see what power you have with this type of signature? The possibilities over here are unlimited in terms of what you can do with this. You guys good? Everybody okay with this? Martin, Emmanuel, Santosh, Surya, Rohan, Palani, you guys good? Long lecture, huh? It doesn't matter what network you launch it from. It really doesn't matter. I can launch it from the outside if you want. So let's just, for that I need to do telnet and all, we need to allow those type of things. First thing that I'll do is I'll clear this guy up, otherwise he's going to be blocked. If you want to do it from the outside, we can do it from the outside. Clear the list. So the poor guy comes back. All right, you want R2 to be, first of all, you need to translate it. I'll say static DMZ comma outside 192.1.50.2 maps over to 1.2. Good. Now what I'll do is on R2, now this guy is coming from outside, so I'll enable telnet over here on R2. So I'm R5. R5 is where? I'm going to try to come in from where? R5 will telnet into 50.2, which is translated. It'll go through the IPS to R2. I need to allow the ACL over here for telnet, and then we'll try the attack. Good? Clear? Now, let's go to 5. Telnet to 192.1.50.2. In, right? You are a food. So R5 sitting over here on the outside did the block, did the attack from here. Came in through here. The IPS has that custom, checks, blocks it. It allowed it, and then because of the signature, it blocks it over here. Now, who will be blocked? 192.1.50.5, this guy will be blocked. You can see that in your signature database, where also monitoring. Sensor management, denied attackers, 50.5. Doesn't matter where it comes from. As long as it goes through the IPS, it's going to get blocked. From this point on, this guy will not be able to come into my network. But one problem. Can he still come in through here? I blocked him. I blocked him from what? Coming in from here, right? Agreed? I have two edges. One is the firewall, and the other part of my network is through this router. Yes, the IPS will block it from here, but this guy can still come in from where? This guy. Or he can come in from here and come through like that. You guys understand what I'm trying to get to? This IPS is only over here. It's not affecting what? It's not impeding this traffic. So he's still coming through here. This guy is still coming through here. I want 50.5 to be blocked over here and 50.5 to be blocked over here. You guys understand what I'm trying to accomplish over here? Martin, Emmanuel, Santosh, Surya, Rohan, Palani. It's going to be really nice when you see it. So yes, I blocked it over here, but I also want to block it on the other devices. First of all, I'll clear it, and then I'll show you the effect of it. So I'll clear it. Right now, he's okay. He's a good guy. Okay. Now I'm going to block him completely all over the place. To do that, I use blocking. Because IPS in inline mode will only block it if it's going through that IPS, that sensor. I want to block it not only over here, but I also want to put the block onto what? The firewall and to this router over here. This is the IPS, same IPS, but it has the management interface over here. In order to do that, I need to set up telnet from where? From IPS to the firewall, so he can do a block over there. IPS to the router to do the block over here. How do I set up telnet? Allow telnet on the firewall, create a profile on the IPS to log in, create the line VTY enable password on R4, allow IPS to log in. Let's take a look. On the firewall, I think I have allowed it already. From the inside, show run telnet. Telnet is allowed from 10.11.11.0, no problems. R4, I need to allow telnet. I don't think I have done that. Password Cisco, login, enable, password will also set that to enable secret to Cisco. So those are my telnet capabilities on my router and my firewall. What I'll do first is set that up. I'll create my device login profiles, which will specify my username passwords. The username password for the firewall, no username. I have a login password, that's a telnet password, which is Cisco by default on a firewall. I don't have an enabled password on the firewall, so I'll leave it blank. I'll create another one for router 4. Router 4 has a telnet password of Cisco and an enabled secret password of Cisco. Create this profile. Basically what I have put in over there is the login password and the enable password. Done. Now I'll define my blocking devices. Who are my blocking devices? I'll add 10.11.11.10, the firewall. I'll use the firewall profile. This device is a PIX or an ASA, and I'll log in using telnet. Once I establish the connection, when I put a block, it's going to put the block on the firewall as well, using the shun command. So I need to set this up. I need to set this relationship up. Same thing for the other one. That's the router, router 4. Just a name. Which profile do I want to use to log in? R4. It is a Cisco router. I'm logging in using Telnet. The other options are SSH if I had SSH. IP address is invalid. 10.11.11.4. All right. These are the two devices I'm going to log into. All right. If everything is hunky-dory right now, I can go to my router and it should show me, show users, that 10.11.11.11 IPS is logged in. He is telling it in right now. He's ready to put a ACL over here. On the firewall, the command is who? Notice 10.11.11 is logged in already. So he is ready to put a block. One extra thing on the router that you need to do, because you're going to be putting this on a, remember what I told you, the difference between a router and a firewall was. Firewall, you do shun. Shun is a global command. On a router, it's done on an interface by putting an ACL. The name of the ACL, it will create automatically. But you need to specify which interface it's going to put it on. In my case, I'm going to put it on F00. So I need to put that. I need to tell router's profile that I'm using. I want you to put the ACL on the outside interface, inbound. So this is where I want to put the ACL. It'll create the ACL automatically. So that is done over here. Router blocking interface. Which interface on the router do you want to block? On 10.11.11.4, I want to block it on fast Ethernet 0/0. Inbound direction. That's where I want to put the ACL. So it knows where to put the block on router 4. Every router might be different. Good? Clear? Now, on that signature that you created, where was that signature? If I go to policies, this is the signature, I think. I can search it by type. Not tuned, custom. Remember that fool? This action is not deny. This action is called request block host. Block is when you log into another device to do it. Deny is when you do it yourself. So on that DMZ segment, I'm going to do the deny. For the other guys, I'm going to do it based on the block. That's going to put a block on the firewall as well as on the, what do you call it? Firewall as well as the router. Click apply. Done. Now let's check. Let's go over here, R5, and do the same telnet. Remember this? You are a fool. Good. Now the effect. If I go to router 4, it has put an ACL on my F00 interface. It is called IDS fast 00 slash. This is just a name. It's a random name it creates. If you look at the contents, it would have blocked 50.5. Permit the rest, but block 50.5. Do you see that? On the firewall, it's not an ACL. What is it? Show shun. It's block 50.5. Now, who did it? It's the IPS management that had telnetted in and did it. That's what I was trying to explain to you. It's not something I'm pushing. I'm actually there. It's from the router's perspective, it's like an administrator actually automatically, he's typing something in. Cool, ain't it? So I showed you the blocking as well, so you could see that's the whole purpose of me building this topology over here. So that I could show you that although my IPS over here is doing the inline block, but that still leaves me vulnerable for this. And if I want to do it, I'll still do a shun over here, and it still leaves me open on the other edge, and I can again do the block over here. That's the whole purpose of building this topology. Save this, takes a lot of time to create it. Save as IPS topology. Good. Last thing I want to do over here, if you have more blocking rules, it will continue to add to the ACL. Yes, correct. It's going to insert it in one at a time. Now, the last thing I want to do over here is something called event filtering. This is called exceptions. Let's say you don't want a particular signature to fire, or a particular administrator, you don't want signatures to fire from a particular IP address because he's the administrator. He's doing pings to figure out the network. You understand that? So if you want to make exceptions to particular signatures, it's called event filtering. It's done under IPS policies, and you specify. I'll click on add over here. I'll specify this is just a name. I'll say admin. I'll say all the signatures for this IP. I'll put the admin IPs as 10.11.11.1 through 9. I believe this is like that. 1 through 9 are the administrators. Any signature that you have, I don't want it to fire for these IPs. I'll exempt it. I'll subtract the signatures. Which signatures? All of them. I don't want any of the signatures for denying happening to them or blocking happening to them. All right, for whom? 10.11.11.1 to 10.11.11.9. Do you see that? Let's say these are my administrators. Apply. I want to make sure I'm not blocked right now. No, I'm not blocked. This guy is out. Denied attackers, I'll clear it. All right. Now, notice what I did. I said 10.11.1, 11.11.1 through 11.11.9 should not fire any alarms. Now, if I go to router 1, which is 10.11.11.1, I will be able to ping 10.11.11.10, no problems. Before I was not, but now I am. Why? I'm exempted. So if you want a certain IP or a range of IPs not to fire a particular alarm or all alarms, you have the ability to do event filtering to do that. So this way it allows you the ability as the administrator to allow these packets to go through. You guys good? Everybody okay with that? That's an event filter that you have. So this is this portion of very simple, but something that you need to know, just in case you don't want yourself to be blocked, and that's how you do it. If let's say you're the administrator and you don't want your administrator to get alarms fired because he's sending a ping and ping is blocked, he will also get blocked. You pick his IP address and you put it into the event filter right over here. Under policies, I put his IP 10.11.11.1 and through 10.11.11.9. All these IPs, don't fire any alarm for them. Don't deny them. Don't request a block for them. So anything that comes from those IPs will be exempted from any of the signatures. This is done in case of a particular administrator doing a particular type of action and you don't want him to get blocked. So you put an exception for that particular IP. You get my point? These are also known as false positives. It is a positive match. Yes, it is an attack, but it's from a known guy. So he's not trying to do anything harm. He's just testing it. So that's what you're doing over here. Doing an event filter for a particular device or IP. All right, guys, you guys good with this? No, you have to do it for IPs. There's no user counts over here. It's all done based on IP. There's no integration with the Active Directory or anything like that. So it's always based on IP addresses. So you have to do it per IP. Good? That knocks out this whole thing over here. I know it's a long lecture, a lot of. So this is done. This is done. This is done. Moving right along. IPS is done. The leftovers are wireless and ICE. All right. You guys okay with this? This thing, the two combined, will take about 4 hours. But you need to do them together. The reason is wireless in this particular one, it's not a wireless CCIE. The only reason they include wireless over here is to integrate it with ICE. They need to be done together. So what I'm going to do next week, and this we need to do on a rack, I'm going to do wireless and ICE together. That will be our last class. All right. This is going to be our last class for this. These are the only two topics left. It takes about 4 hours to do both of them together, if that. Because we have extra time on that day, we'll touch on the lab. What are the different things that you need to do for the lab? I'll touch on that as well. But next week, we'll do it on Sunday. We'll do it. This is the time for next week. Sunday, we'll do the lab as well as we'll discuss it. But this is the time that we'll do it. We'll do it on Sunday, IST, 6:30. So whoever you know, your friends, whoever comes into the class who's not here, just let them know the last class for this one, which is going to be wireless, security, and ICE, which go hand in hand. I'll show you the link between them next week. Will be done next week, 6:30 IST. I'll be in London next week, so the timing's a little different. Just an hour later. But we'll knock out the entire thing at that time. We'll do it together. We'll do the lab on it as well. Good? The wireless portion on the exam is not tested, but it's configured. So you need to know how to link them up. Any questions, guys? Okay, 1 second. This is a long question. Surya, send me an email. I'll send you the video on ICE. Done. I'll send you a link, download the videos for ICE. All right, guys, take care. See you guys next week, Sunday at 6:30. Take care. Bye now. Thank you, guys.